Alright guys, this is my reassessment for the standard done on work energy. And I am doing number 17 in the book from chapter 6. And the question asks, Jim rides his skateboard down a ramp that is in the shape of a quarter circle with a radius of 5.50 meters. At the bottom of the ramp, Jim is moving at 9.0 meters per second. Jim and his skateboard have a mass of 65.0 kilograms. How much work is done by the friction as the skateboard goes down the ramp? So as you can see here, I have my little free body diagram. Not necessarily a free body diagram, but a diagram of what the half quarter pipe looks like, and Jim at the top with his skateboard. Over here I have my known values. Sorry, it's kind of blurry. And the radius of the circle is 5.50 meters. The mass of Jim is 60 kilograms with the skateboard. And towards the bottom, his speed increases to 9.00 meters per second. Okay, so the first thing you got to take into consideration here is that, Jim is at the top of a half pipe. So that's technically considered gravitational potential energy. So the first thing I did was I did my delta UG, which is gravitational potential energy, is equal to mass times gravity times delta Y. There's actually no final gravitational potential energy, being that he's decreasing going down the ramp, which actually turns into kinetic energy. So I rewrite the formula: 0 minus mg delta y1, which can also be considered m times g times h. Multiply that all together: 65.0 times 9.8 times 5.50, and I get 3,503.5 joules for the gravitational potential energy. So the next thing it says that towards the bottom of the ramp, Jim is moving at 9.0 meters per second. So that kind of gives me a clue to what to do there. So I actually do my delta K formula, which is kinetic energy, which is 1/2 mv squared final minus 1/2 mv squared initial. In this case, there's actually no initial velocity, so I can just substitute in 0 for that, and it gives me 1/2 mv squared. I plug in my mass, which is 65.0 kilograms, and my velocity towards the bottom, which is 9.0, and it gives me 2,632.5. But the question asks for what is the friction as the skateboard goes down the ramp. So generally that's all you really have to do is do your work formula. So W is equal to gravitational potential energy minus the kinetic energy that we found. And I subtract the gravitational potential energy from the kinetic energy, and it gives me 871 joules.